Hello, Port Discovery friends. My name is Miss Sarah, and today we are going to create our very own lava lamps. Now, before we get started, I just want to remind all of my friends to keep these rules in mind. First things first, let's make sure that we have our parents and guardians' supervision and permission before using any of the materials we're using today, most of which you can find in your own household. The second thing is to make sure that the space you're using is either ready to go and easy to get messy and clean up, or, like I have, use a material to put down to keep your surface clean. Once you have those, you're ready to get started. And I'm just going to bring out our materials and go over what you're going to be using them for. So, first things first, you're going to need a glass container, or what I'm using, a jar. Anything that at least allows you to see through is the best thing to use. You can use a cup or a mug. Things that are not see-through are harder to use and you can't see the experiment. So I'll be using a jar and I'm going to be removing the lid for now. The next thing you're going to need is vegetable oil. Now, while I'd like to give you the exact measurements that you would need for this, the thing is, depending on what jar you use and the size of it, is dependent on how much vegetable oil you're going to use. Because I'm using a very large jar, so all my friends can see the experiment, I'm going to be using a lot of vegetable oil because I'm going to need to fill the jar almost to the top. The next thing you're going to use is water. You don't need a lot of water. I have a decent amount, but that's just so I can show you how much you should be putting in. The next material is food coloring. Just as a reminder, if you want to use food coloring, awesome, but try not to add too many colors. The food coloring is going to mix inside the water, so if you use a lot of colors, you might get a darker color that you didn't want, or black entirely. Unless you want it, then that's fine. I'm just going to be using red because I love that color. The last thing you'll need is 2 Alka-Seltzer tablets. These are going to be used for the reaction, and you don't need a lot of these unless you want to keep the reaction going. So, that in mind, I'm going to set all my materials aside that I'm not currently using. Keep the vegetable oil and the jar out. Put the water and food coloring aside, that way you can take your time, make sure you don't bump into anything. So, with that in mind, let's get moving. Sorry. Alright, so I'm going to use my vegetable oil and I'm going to fill it to the top. I don't have to do it fast. I'm going to take my time and make sure I'm measuring it. My goal is to get it to about here. Vegetable oil is going to be the main component, and I'm just going to slowly pour it in. Use as much. Take your time. There's no need to rush. We're going to keep pouring, and I might even use the whole thing. But I'm just about it. Alright, very nice. And what I'm going to do, and what you should do, is recap my vegetable oil and put it aside since I will no longer need it. The next thing I'm going to use is just a little bit of water. You don't need a lot for this experiment, but I'm going to try to fill it up all the way to here. And I'm going to slowly pour it in, taking my time, watching it go. Now, excellent. What you're going to see, and what you're probably noticing right now, is that there's 2 different layers. It looks like the water and the vegetable oil don't mix. For those of you who don't know, vegetable oil and water are at different densities and their molecules don't mix together. Think of vegetable oil as a feather on top of the pond. Because it's lighter than water, it floats on top of it. Whereas water, compared to vegetable oil, is like a rock. When you throw the rock into the pond, it sinks to the surface. The 2 liquids create their 2 different things. So while those settle, let's get our food coloring in place. Now, remember, like I said, depending on what color you want to create, just make sure you know that adding different colors will eventually mix in the water. So there's no need to create a lot of colors. I'm only going to use about 4 drops of this. Now, can anybody shout out what happens when I add food coloring to water? I've already said it, but if you didn't know, food coloring will mix into the water and change its color. So if I add this to water, I'll create red. Now, with that in mind, what do you think happens when I add the food coloring to the oil? Do you think it's going to mix in like the water? Or do you think it's going to go to the water? Why don't we find out? So while water is settling, I'm going to add our food coloring. And I'm going to add 1, 2, 3, 4. And I'm going to give big drops. And as you can kind of see, a little hard with the camera, they are sinking to the bottom. See, like the water, the food coloring is the same density and the same molecule makeup. So what happens is it doesn't reach the bottom, or it reaches the bottom and mixes with the water. You can already see that our food coloring is starting to bleed into our water. whereas it doesn't even combine with the oil. Isn't that amazing? So, with that in mind, I'm going to let that settle, and I'm going to get out the final component to our experiment to create our very own lava lamps, our Alka-Seltzer tablets. So, what you want to do with these tablets is basically break them in half. You can break them into smaller pieces, but I want to make sure that they're enough that you can see the chemical reaction. Now, I did my best to make it in half, but I think that's pretty good. I'm going to actually use the bigger one for this one, just to create a bigger reaction. If you want to keep it going continuously, the best thing to do is to just add little pieces in. With that in mind, that it's bleeded in, there's no need to stir or even mix this in. The chemical reaction is going to do enough for us. So, I'm going to try to drop it in, center, and depending on how it goes, we'll see our chemical reaction. Now, we already see it, and I'm going to put the cap back on just so I can move it over closer to the computer, and that way you can see what's going on. As you can start to see, something's fizzling. And soon, we're going to see what's happening. Now, what you're noticing is that the water is fizzing up to the top and then dropping back down in slow molecules. Don't feel discouraged if your thing goes to the side, it usually does that, and that's the creation of what it's doing. Just like a lava lamp moving up and down. Now I'm going to add the rest of the Alka-Seltzer tablet just for fun. And you're probably wondering, why is this doing this, Miss Sarah? Like you said before, water is denser than oil, so shouldn't it stay in the bottom? And if it goes all the way to the top, why doesn't it stay at the top? And that is exactly the reaction we're creating, just the same as a lava lamp. You see, when the Alka-Seltzer goes into the bottom, it creates a chemical reaction, merging water molecules with carbon dioxide, which, as you know, gases are often lighter than water. So, it's also lighter than oil. So what happens is, the merged chemicals, or molecules now, go all the way to the top. And what happens when it gets to the top? Well, the gas gets released, and then the water becomes just water again. And, as I've already stated, water is denser than oil. So the water goes slowly back to the bottom, creating a continuous amount of chemical reaction. And a really cool thing to watch. Now, lava lamps are exactly the same, just a different method. They use heat instead of Alka-Seltzer tablets. You see, heat, when it's introduced to molecules, expands them and makes them lighter. So, the molecules slowly start coming to the top. But what happens when the heat is no longer around the surface of the top of the lava lamp? Well, they go back to their original density and sink to the bottom. Same as here. Water is introduced to carbon dioxide. Dioxide and water go all the way up the oil because it's lighter, and then it's released and goes back down to the bottom. I'm going to add a little bit more just to keep the reaction going. And then, eventually, when the Alka-Seltzer tablet is worn out, it eventually just kind of floats to the top and disappears. Now, I'm at the end of my experiment, and I've had so much fun showing you this really cool reaction. If you're interested in trying this out, I promise, as you saw, it was super easy and a super quick experiment. And as long as you have enough Alka-Seltzer tablets, you can keep going as long as you'd like. Like so. Now, if you want to try this experiment out, please show us below or tell us how it went. Thank you so much for coming out. I hope you learned a thing or two, and I hope that you enjoyed watching this experiment with me. Thank you so much, friends. My name is Miss Sarah, and thank you for coming out today. Goodbye now!